Let me go further after the standard deviation. Standard deviation is an important part of this, right? Okay, let me do with further. Okay, coefficient of variations. That is same thing. Coefficient of variation is you can find the deviation between the two series. To find the coefficient of standard deviation, that is called the coefficient of variance. Coefficient of variation, that is in the short form we say that CV. CV is the coefficient of variation. Formula for this is the standard deviation divided by mean into 100, right? See, for example, how do we calculate, why we calculate the coefficient of variation? See, let me take an example of run scored by the two batsmen in Indian team, right? Fine. Okay, let me take one batsman as a KL Rahul, and the second one we can take second. Let me take anyone. Dhoni. Leave it. The captain. I forgot the name of captain. Who is the captain of Indian cricket team? Let's take Virat Kohli. Fine. In these two batsmen, let me take a score of these two batsmen. Fine. So one batsman is what? Let me take a Virat Kohli. Virat Kohli comes and score as much as possible, right? Try to score as much as possible. Either he score well or he outs. Fine. Similarly, let me take a KL Rahul. KL Rahul comes and he sticks to the strike, right? Yes, he sticks to the strike, not make as much as a run, but yeah, stick to the strike. Fine. Fine. So, wait. Right. So, if we count the score of these two batsmen for the 12th inning, so what we found, coefficient of variation of KL Rahul is much better than Virat Kohli. Let me take example of this kind because Virat Kohli either makes a run or out, or KL Rahul is steady in the crease. Right? So that means the variation is much more in Virat Kohli rather than KL Rahul. Right? So variation is kind of either out or make a run. It's that kind of thing. Right? Whose variation is more, that means he is less stable batsman, right? If variation is less, that means more stable batsman. Okay, see, these are the some relationship between the values. Mean plus minus quartile deviation. Let me take any value of mean and any value of QD, then mean value plus QD. For example, let the values are only 50 and QD is 2. Mean plus minus QD covers 50% area. Mean plus minus MD covers this area, and so on. This see the calculation of it. No need to do the calculation for this. Just read this result or the percentage. That's it. Right? QD is equals to 2 by 3 of SD, and QD is equals to 5 by 6 of MD. This is the relation among pre-deviation for SD. That means 4 times standard deviation equals to 5 times mean deviation equals to 6 times quartile deviation. This is not in your course, business purposes and this. See, next chapter is correlation analysis, right? So what is correlation analysis? Correlation is what? Correlation is a relationship between the two variables. Relationship between the two variables, right? If they are the two series, if they are the two series, then the relationship between the two series is called the correlation. This is the most important topic of this. Probably one question may be come from this topic, correlation, right? So this is a very important topic. See, now what is a correlation? Exactly what is correlation? See, let me take a two series, right? Let me take a two series. Two series is like one is a rainfall, other one is a temperature. One is rainfall, other one is a temperature. If the rainfall increases, then temperature decreases. If the rainfall increases, then the temperature decreases. So this is what we call if one series is increasing, one term is increasing, the second term is decreasing. So we say if one is increasing, second is decreasing, we say this one is increasing, second one decreasing. That means it is a reversible impact on other, right? So that means one is increasing, second one is decreasing. This is called a negative correlation. That means it's a negative effect on the other, right? So if one series is increasing, second one is also increasing. That is called a positive correlation. Got it? Clear? So we have either positive correlation or negative correlation. Right? If there is no change, we say that there is no correlation. Right? The value of correlation always lies between -1 to +1. -1 to +1. Value of correlation lies between -1 to +1. If values lies between -1 to 0, between -1 to 0, it is a negative correlation. If values lies between 0 to +1, it is called a positive correlation. It is called positive correlation. Fine. So I told you if one series is increasing, second one is decreasing, it is called a increasing correlation, that is positive correlation. If one series is increasing and second series is decreasing, we say negative correlation. We say negative correlation. Is that clear? Is that clear? Yes, clear?
Yes, sir.
Okay. Now, so type of correlation means first one is a negative and positive correlation, which I have already covered. Second one is linear and non-linear, right? So I told you that there is two type of series, because we have to find the correlation between two series. Understood. Now, secondly, linear and non-linear. If there, I told you that there is two type of two series, right? Let me name it. One is X series, second one is a Y series. If we draw the graph of these two terms, these two series, if the graph comes in the straight line, then it is a linear. If graph doesn't come on the straight line, then it is a non-linear, right? See, like that. If it is in the straight line, like this straight line, this is a linear. Not straight line, this is non-linear, right? Is that clear? Now, method of studying the correlation. Method of studying correlation. This is important. First one is a scatter diagram. Second one is the most important. Carl Pearson coefficient of correlation. Carl Pearson coefficient of correlation. This one is the most important, right? Two-way frequency is not in your course. Third one is the rank method. This is important, also important. The Carl Pearson and the rank, these two is the important. Content division is not in the course. Now come to the scatter diagram. See what is a scatter diagram. Scatter diagram is it is a diagrammatical representation of correlation, right? We have two type of data. If we draw the graph of these data, first one is this one is a X series horizontal and Y series vertical, right? If you plot the points if we plot the points on these graphs, if it comes in a straight line, if it is comes in straight line, that is called the perfect positive correlation. If all points comes in the straight line, that is called a perfect positive correlation. That is called the perfect positive correlation. If it it is upward slope, that means it is going on upward. If it is going downward, we call the downward slope. This is called a perfect negative correlation. Perfect negative correlation, right? Now, low degree positive and low degree negative, high degree positive, high degree negative, and this. See, look at this high degree positive correlation. What is the difference in this? If all these points comes in the straight line, all these points if comes in the straight line, then it is called a perfect positive correlation. It is called a perfect positive correlation, right? Now look at this graph. Look at this graph. What happened to these graphs? These points, right? It means if all the points, if we draw an imaginary line, let me draw one imaginary line, straight line, and if all the points, these points comes very close to that straight line, if all these points comes very close to that straight line, we called as a high degree positive correlation. High degree positive correlation. Similarly, if these points are far from that imaginary line, far from, not very close, far like this. These points are very far, right? These are the far. We say low degree positive correlation because it's going upward, so it is a positive. In the similar way, if it is the downward, we say high degree negative correlation if the points are very close to that imaginary line. If the points are far from that, we call the low degree negative correlation. Got it? Is that clear? Is it clear, beta?
Yes, sir.
If there is no relation between these two series, we say no correlation. Either coming to upward and downward or downward to upward, or there is no relationship like this. So we say there is a no correlation. Right? See, I already told you that the value of the correlation lies between -1 to +1, -1 to +1, right? If value is R, we generally denote correlation by R, small r, right? So if the value of R is +1, if the value of R is +1, we say perfect positive correlation. If value of R is -1, we say perfect negative correlation, right? If R is 0, that means no correlation. No correlation, right? Now, so in the high degree positive, values are close to 1, +1. High degree negative, values are very close to -1. Low degree, that means value is close to 0. Similarly, this is negative side close to 0. That's it. This is the scatter diagram. Is that clear, beta? Any doubt? Any doubt, beta? Is that clear? Scatter. Let me do further. Come to this Karl-Pearson coefficient of correlation. This is an important method. Karl-Pearson coefficient of correlation. right? In general, the formula for the R, I already told you that it is denoted by a small r. So value of the R is covariance of x and y upon standard deviation of x upon standard deviation of y, right? Now, now for this shortcut, we can write the formula like this. Now, look at this. General formula is R is covariance of x and y upon standard deviation of x upon standard deviation of y. Standard deviation of x upon standard deviation of y, right? Now, now look at this formula, right? That is the summation of dx into dy upon summation of upon square root of summation of dx square into dy square, right? Dx is x minus, here it is right, x minus x bar. You can take x minus a for the shortcut. X minus a, we denoted as a dx. Similarly, y minus v as a b is the assuming from y series, right? Now, look at this example. No, leave it, because this is this dx is x minus x bar. So you must take this formula. You must take this formula. The last one, this one, right? Look at this formula. If we open, this, expand this formula, it becomes n. N is number of number types. Summation of xy minus summation of x into summation of y upon in square root and summation of x square minus summation of x ka whole square. Similarly, n summation of y square minus summation of y whole square. Now look at this. In this, we have to find the calculated coefficient of correlation between the expenditure and the sales, right? These two series are given. Right? Here, let me take up one is x, second one is y. Fine. Okay. In this series, what we have done, we just add these numbers. It comes to be a 650 and add these series. It comes to be 650. So total number of terms is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms, right? So for x bar is 650 divided by 10, that is 65. Similarly, for this, it is 66. In dx terms as x minus x bar, we put in this formula. Obviously, x minus x bar total always comes to 0, so its sum is 0. Similarly, for the y, the similar way. Next, we find dx square, then dy square, then dx into dy. Okay. We make total sum of dx, sum of dy. Obviously, it comes in the 0. That dx square, sum of these, dy square, sum of dy square series, and summation of dx dy. That is these terms, right? Put in this formula, and it comes to a 0.7804. Okay, right? So this is a correlation. This is a positive correlation. That means, what did this mean? This is positive number, 0.78. and obviously it's close to one, not much close, but yeah, apart from zero. If we see the compare with the zero and one, it is much close to one, right? So that means it is more positive. Fine. So this is advertisement and sales. What this means, if we increase the advertisement expenses, then obviously sales. That means one series is increasing, second series is also increasing, right? So that means if advertising expenses increases, then obviously sales increases, right? We can use this formula also. I told you, and summation of x y minus summation of x upon summation of y upon n under root of summation of x square minus summation of x whole square into n summation of y square minus summation of y whole square. Right? If we replace simple x, these y by shortcut wala dx, right? So which we already studied earlier. So that is that we called a deviation, right? So deviation is what? X minus a. Dx is x minus a, right? Similarly, dy is x minus b. So in this, a and b are the uh, assuming, right? A for the X series and B for the Y series. Now, here they put X minus A upon H, either if there is any kind of thing which we can divide. Generally, what we do, we write X minus A only, right? Similarly for X minus. Look at this example, right? This is an important example. Fine. Calculate the coefficient of correlation for the ages of a husband and the wife. Age of husband given, age of wife given, right? Right. Now look at this example. X series, Y series, right? What he had done, he made a total, right? Total number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number is 10, right? X is given, Y is given, right? So for X bar is if divided by 10, it comes to 31.1. Similarly, for the Y, it comes to be a 25.7. So in this case, what we have seen, there is no any value because the mean comes in the decimal. If it multiply with, sorry, if we make a difference in this decimal, so it's very difficult to take the calculation. So what we do, we do one thing, we just take out any value from here, or we assume any value, which we called as assume mean, right? A from the first series. So what we have seen, the approximately mean is 31.1, right? So what he took assume mean as 31. Similarly, for the second case, it's at 25.7, he took 25. That is close to this. Again, similarly, we find the summation of u, summation of v, u square, v square, and uv. Put in this formula. Do one thing, do this question because this is the most important question. Do this, right? I'll give you 5 minutes. See in this values are very, we put these formula, sorry, these values in this formula. Calculating, we get 0.9956. That is the value is very close to 1. That means perfect positive correlation. Clear? Is this clear? Right. So this is a Karl-Fisher coefficient and coefficient. Let me do the next. This is not in your course syllabus. Now comes to the rank coefficient, the rank. The formula for the rank is we either put the capital R or this, and this is called a rho, right? This is a Greek word rho, right? The formula for this is the 1 minus 6 summation of d square upon n within a bracket n square minus 1. D is the difference between the rank. D is the difference between the rank, right? And n is the number of pair, right? Now, see, this two type of case when the actual ranks are given or ranks are not given, all right? Let me do when the ranks are not given, because if rank is given, that is a direct way to put the formula. See, the first example, the ranks are given, right? And the rank of the 15 students in the two subjects are given below that kind of this. Rank of in subject A and in subject B, right? This we call the R1, this is we call the R2. Rank 1, R1 is the rank of the first series, R2 is the rank of the second series. D is the difference between the rank, difference between the rank. That is 1 minus 10, that is minus 9, 2 minus 7, minus 5, 3 minus 2, 1, and so on like this. Next, D square square of this, right? So D square comes to be 272. Put in this formula, it comes to be 0.51. This is the rank. Fine. Right.